Hello friends, this is Praveen Pawar. In this video, we will discuss the question paper of UGC-NET July 2016. This is paper 2 of electronic science. So first we will discuss from question number 1 to 25. So here is question number 1. In JFET, the transconductance can be expressed as. So in the options, direct expression is given for transconductance, which is represented as GM. So its correct option is 2. GM is equal to minus 2 IDSS upon VP into 1 minus VGS upon VP. So there's minus not given. So correct option is 2. An electrodynamic generator is used to convert. So from name it is clear that generator is used to convert the mechanical energy into electrical energy. So correct option is motion into voltage. It's reverse, electrical to mechanical is the function known as a motor. The effect of adding poles and zeros can be determined for determining phase in gain margin by Bode plot. So correct option is fourth one, Bode plot. The small signal model of a tunnel diode in negative resistance region is. So correct option is 2. So I'd like to explain the characteristic of this tunnel diode, which looks like this. As we is like this. As we increase the voltage, our current is decreases. So that is the negative resistance region. Correct option is second one. Question number 5. The logic function implemented by the circuit below is. For any multiplexer, you have to evaluate the output. So for this, I'd like to give you a generalized expression. So y is equal to I naught S1 bar S0 bar plus I1 S1 bar S0 plus I2 S1 S0 bar plus I3 S1 S0 for all four combinations of the select lines, their corresponding inputs. So here I0 would be, here ground is 0, so this is your NOT gate, its negation would be 1, and again its NOT gate, its negation would be 0. So I0 is here 0, similar, and I1 and I2 is 1 here, and I3 is not given, so it would be 0 here. We'll take it as 0. So output Y would be S1 bar S0 plus S1 S0 bar. S1 S0 is P and Q respectively. So this expression is for XOR operation. So correct option is P XOR Q. Correct option is third one. Question number 6. For the following circuit, for making the output high, the input combination must be. So here to solve such type of problems, you will see there are 3 inputs, and each value may be either 0 or 1. So there will be 8 possible combinations. So for each combination, you can find the output by writing truth table and obtaining the Boolean algebra of the expression. So it is a time consuming problem. It's better to pick the options, the values of ABC, and put in the put here and get the output. So first I will take what A is equal to 0, B equal to 0, and C is equal to 1. For this XNOR operation, if input is 0 0, would be, this is 0 and it would be 1, and XOR output would be 0. Here C is 1. So output of XNOR is 1 0, output of XOR is 1, and 1 1 is still is 0, and its negation is 1. So correct option is first one. And for other values, if you try, so first I will try, so next I will try fourth one. A equal to 0, B equal to 1, and C is equal to 1. So for this XNOR or 0 1 would be 0, and XOR would be 1, and C is 1 here. So 0 1 is 1, 1 1 is 0. So again negation is 1. So fourth one is also giving the correct answer, and second and third one is not correct option. You can check yourself. Question number 7. Number of times the instruction sequence below will loop before coming out of loop is. So here instructions are given. MOV move AL, 00H. H is representing here that this data is given in hexadecimal form. So this is 8-bit data. The operation of this instruction is that AL represent to 8-bit register, and this 8-bit data will move into the AL register. So contents of AL after execution of this instruction would be 0 0 in hexadecimal. A1 indicates the address of the instruction. INCAL, it means increment AL. So contents of accumulate this AL register, 8-bit register will increment by 1. So after execution of this instruction, it would be 1 0 1. Contents of AL would be 0. J and Z A1. This is jump instruction. The operation of this instruction is that J and Z jump at non-zero. When zero flag is 0, it will jump at the address which is given here. So this is address indicates the address of the instruction in the program. So and when it goes to 0, when the contents of the accumulator or register is non-zero. When it becomes 0, our 0 flag will be set and indicates that the register contents has been 0. So it will jump to this, and again it will increment by 1. Now it will be 2. Again it is non-zero. So it goes up to FF. So this is in hexadecimals. Its decimal value is 255. So this loop have run 255 times, and next again this loop will run, and FF it would be 0 0, and carry flag will be generated by 1. So here register contents will be 0. Our 0 flag will be now set, and it will not jump again. The next it will come out of the program. So this loop will execute 255 plus 1, 256 times. Our correct option is 1. Now question number 8. The number of wait states required to interface 8279 to 8086 with 8 MHz clock are. So the correct option is 2. There are 2 wait states used so that device can function with an 8 MHz frequency. Correct option is 2. Question number 9. Which combination of the integer variables x, y and z makes the variable to get the value 4 in the following expression? So to get the value 4, the variables x, y and z should be 4. So only 3 and 4th may be correct one. So here we will see in the expression x is greater than y, x is greater than z, y is greater than z. So here only 4th expression is correct. So here we will see x is greater than y. So here 3 is not greater than y. So we'll leave the first expression, and the second one is y is greater than z. So here 4 is greater than 2. So this fourth one is the correct, which replace the value of y and gives the value of expression, that is 4. So fourth one is the correct answer. Question number 10. Consider the following program. Main plot a is equal to 0.3 and b is equal to 0.5. If b is less than 0.6 and if a is less than 0.3, then printf xyz. So this is not true, and else printf abc. So this is correct because here a is not less than 0.3. So printf abc. Correct option is third one. For a matched junction, scattering parameters are given values, which one of the following is true? So for merged junction, would be correct option is fourth one, S21 is equal to 1. The diagonal element is 0, 0. So S21 is equal to 1. Question number 12. The number of bits per sample in a PCM system is increased from 8 to 16. The bandwidth of the system would increase. So for PCM system, we know that bandwidth is NFS, where N is the number of bits. So here number of bits are going to double. So our bandwidth will also double. So it will increase by 2 times. Question number 13. An infrared LED is optically coupled to a photodiode. When LED is turned off, the reading on an ammeter in series with the reverse bias photodiode will be. So when LED will turn off, the current will be decreased. So correspondingly, ammeter reading will also decrease. So option number 2 is correct. Question number 14. After firing a SCR, the gating pulse is removed. The current in the SCR will. So it would be same. Correct option is first one. Question number 15. A signal f of t is defined as 1 minus alpha t to the power minus alpha t. Its Laplace transform will be. So first I will distribute this given signal f of t, which is e to the power minus alpha t minus alpha t e to the power minus alpha t. So Laplace transform of this e to the power minus alpha t is 1 upon s plus alpha minus, here alpha is the constant, and multiply by t will give the expression this 1 plus 1 upon s plus alpha whole square. So on solving this, we will get this s plus alpha whole square, and here it would be s plus alpha minus alpha. So correct answer is s upon s plus alpha whole square. Second one is the correct answer. Question number 16. For intrinsic semiconductor, the conductivity is, so conductivity is represented as eta is equal to nq mu n plus pq mu p. So this is the expression is matched with this option A, and if you take n according to mass action law, it is n into p is equal to ni square, and for intrinsic it is n is equal to p. So B option is also matched. So A and B are correct. First one is the correct answer. Now question number 17. Read the following statements. The gain crossover is a point on the L of j omega plot at which the magnitude of L of j omega is equal to 1. This statement is correct. The gain crossover is a point on the L of j omega plot at which the magnitude of this is equal to 0. This is not correct. The gain crossover frequency is the frequency of L of j omega where magnitude of this L of j omega is equal to 1. This is also correct, and D1 is not correct. So A and C are correct. Option number 2 is correct. Question number 18. In a PN junction diode, if A is the area of a junction, then the transition capacitance CT is. So direct formula is given in the options. So B is the correct one. So correct answer is B, third one. B is correct, B is wrong. Question number 19. In a resistive ladder network used in n-bit digital to analog converters, the following statements are given. LSB, which is lower significant bit, weight is given by 1 over 2 to the power n minus 1. So this is correct, and this one is wrong. The sum of all weights is equal to 1. This is also correct, and so this is wrong. A and C are correct. Second one is the correct answer. Question number 20. The 8085 microprocessor enters into bus idle machine cycle whenever a INTR interrupt is recognized. This is not correct. RST X.5 is recognized. Here X is representing here 7, 7.5, 6.5, 5.5. So this is correct. When content of register B is 00, this is not correct. DAD, which is a double addition, register pair instruction is executed. So this is also correct. The operation of this instruction is that the contents of HL register pair I mean 16-bit data is added with the register pair which is indicated in the instruction as an operand. So when this instruction is executed, our bus goes to 85 microprocessor enters into the bus idle machine side. So B and D is correct. B and D are correct. Second one is the correct answer. Question number 21. If X is an one-dimensional array, then so its the correct option is C. This pointer X plus I is same as ampersand X of, and D1 is also correct. So C and D are correct. Third one is the correct. Question number 22. For transmission lines, following statements are given. There is no cutoff frequency for TEM in coaxial cables. This is correct. Coaxial cables are useful up to 100 megahertz only. As we know that coaxial cables can support up to 1 gigahertz. So this statement is not correct. Waveguides don't support TEM wave. This statement is correct. Waveguides don't support TEM. All the frequencies above cutoff flow through waveguides. This is also correct. So A, C, and D are correct. Second one is the correct answer. Question number 23. Which of the following statements are true for delta modulation? The modulation is digital in nature. So this is correct. Modulation is analog in nature. This is not correct. Better signal to noise ratio than PCM. Delta modulation have better SNR than PCM. So this is also correct. Slope overload occurs in delta modulation. So as a characteristic of delta modulation, there is a slope overload. So this is also correct. A, C, and D are correct. The third one is the correct answer. Question number 24. Which of the below mentioned statements are correct with respect of semiconductor laser? PN junctions can be formed by using direct band gap semiconductors. So this is also correct. Emitted radiations should be monochromatic and coherent. This is also correct. Emitted radiations should be monochromatic and all are in same phase. This is also correct. Emitted radiations should be monochromatic and spontaneous. This is not correct, not spontaneous. As we know, the full form of laser is light amplification, stimulated emission of radiation. So, I would like to clear this point, direct band gap. So, there are two types of semiconductor: direct band gap semiconductor and indirect band gap semiconductor. In the example of direct band gap is gallium arsenide or LEDs comes under this category. Laser is also. So during the recombinations, the energy is released in the form of light in direct band gap. The falling electrons from conduction band to valence band will be directly falling without any collision with the crystals of the atom, and energy is released in the form of light. On the other hand, in indirect band gap semiconductor, most of the falling electrons from conduction band to valence band will be colliding with the crystals of the atom, and the crystals will be absorbing the energy from the falling electron, and they get heated up, and the energy is released in the form of heat. So just like germanium and silicon, this semiconductor comes under this category, and energy is released in the form of heat. So there's a difference in direct band gap and indirect band gap. Question number 25. Consider a two-port network shown in the following figure, and the Z parameters. We have to find the Z parameters, Z11 and Z21. So I like to give in equations how to find Z parameters. So Z11 is equal to V1 upon I1 at I2 is equal to 0. So I will write first equation, which is one change I will do to get the correct answer. I will change the polarity of this. This is our minus and this is plus, and this voltage is 10 E1. Okay, so here I will write E1 is equal to 2 I1 plus 4 I1, because I2 is 0 here, so there is only 4 I1 minus 10 E1. This is 10 E1. Okay, so on solving this, we will get E1 upon I1 is equal to 4 plus 2 6 upon 11, and it is nothing but Z11. So this one C1 is correct. And next for Z21, which is V2 upon I1 at I2 is equal to 0. So here it is E2, which is equal to 4 I1 minus 10 E1. So on putting the value of E1 from this equation, which is equal to E2 is equal to 4 I1 minus 10 into E1 is equal to 6 upon 11 I1. So on solving this, E2 upon I1 is equal to 11 for the 44 minus 60, which is minus 16 upon 11. So it is nothing but Z21. So D1 is the correct one. So C and D is correct. Option 4 is the correct one. So that's all about for this video. We will continue in the next video. Thanks for your kind attention. Your all suggestions are most welcome. Please like, share and comment and subscribe my channel Praveen 25488. All the best friends. Thank you very much. Thanks a lot.